All right. Thanks everyone for joining. I just want to take a minute and talk about a couple things, and I'll hand it over to Malcolm. Um, yeah, first of all, this is the first session of our revived Estes Park group, and most people don't know about that, but there are a few people in the community who were around when in Estes Park, Colorado, this group met and talked about different tools in the field and had educational sessions and demonstrations. It was never, sales demos. It was really just, informal sharing the tools and the topics around them and um, giving everyone a chance to discover what's available in the field and see if it's a fit in their practice. Uh, so recently, the data-centric architecture forum was held in Fort Collins, Colorado, and Malcolm came and told us all about GraphCentric and the topics surrounding that he'll get into in this presentation. But we thought it was really interesting, and we wanted to let him share what he's up to with the broader community here. So we're really happy to have him, and I'll go ahead and let him introduce himself and tell you what he's doing.
Yeah, hello everyone. I'm Malcolm Sparks. Hello to people on the call and also those of you watching the recording. I live in England and it's a kind of bright sunny evening here, but most of you I know are in kind of mountain time. I got into data centrism around 5 years ago, but I didn't really know what it was. I kind of came and I think I did sign a manifesto, but it's a real honor to come and actually talk in front of you at the Estes Park group. And it was a lovely trip that we made out to Fort Collins for the DCAF last month. And then prior to that, the Knowledge Graph conference. So I want to just do a few slides today. I'm going to cover this topic that I did cover at DCAF, but I'm going to do it in a slightly different way today. And this is recorded, okay? So this will be, whereas DCAF wasn't. So this is 4 presentations I've made, but this is the one I'm going to give, which is called Options and Strategies for Access Control in Data-Centric Systems. And I'll introduce why that's important. A little bit more about me. I'm the founder of GraphCentric, but we're only 6 months old. So before that, I did a lot of work around, really, I'm a backend developer. So I've been trying to create generic servers for almost getting on 30 years. I had a long history in Java and enterprise beans, and then as the web began to emerge in REST. And so I'm really a web developer, and I have had a bit of experience modeling entity relationship diagrams for SQL early in my career, but I'm not a modeler, I'm not an ontologist, I'm a kind of a software developer. I do have a weekly newsletter called GraphCentric Weekly, which you can find. It's a LinkedIn newsletter. But I discovered linked data around 2010 at a financial institution, and I was completely bowled over by it. I thought it was absolutely the right way to build applications. But I was in an institution of thousands and thousands of applications, and it was never going to become a data-centric universe. I used to talk about the desire I had that every piece of information in my institution could be an IRI, and yet it wasn't. Nothing was really findable or addressable. And so that's how I kind of got into linked data. And then I had a few years of really building financial systems. Yeah, I think I found this old book in my library called The Zen of CSS Design. And this is a sort of throwback to the past, sort of love letter to CSS. And it's really kind of an analogy of that the web started out with this lovely separation between content, the stuff that matters, and presentation, which was CSS. In fact, there's a little love letter to this idea that we've got in the website. So if I just click onto scroll down through the deck, or I click on end, and I have a theme explorer here. We did one for New York, and we did one for Fort Collins, but I never really showed it. But this was the presentation theme that I wanted to have for decaf. But unfortunately, if you look at the top left, all of the header fonts were in this kind of very ornate. This is what the AI thought that would represent Fort Collins. Anyway, I've had to tone that down a bit. So let's start again with that presentation. And this, by the way, I mean a little bit about my process here. This is a data-centric slide deck where every slide is a resource on the web. Every slide has links to other slides, and there is no editor to this this slide deck. There's no kind of lovely PowerPoint diagram editor. So the way I build slide decks, and this has been, well, this is the first time I've really done it, is that I've made the slide deck itself very controllable by making it web resources and allowing those web resources to be edited remotely by AIs, just by giving the discovery clues. And so rather than actually sit down with a mouse and type my slides in, I kind of ask the AI to edit the slide deck live, and it goes onto the website and it makes the changes. So it's a bit of an experiment today. This is the first time I've given a presentation where I haven't been responsible for any of the words or any of the pictures. I've just kind of asked and prompted and reviewed. So
the rest of it I will leave you to enjoy.
Okay. So my journey to data centrism was really this diagram in 2020 that I wrote kind of independently before I knew anything about the data-centric manifesto. And I had this idea. This slide looks very similar to a slide that Dave McComb gave in the Knowledge
Yes, it is back.
conference. And
you're the man, per usual.
You look at it on the left.
Right, Dean. Thank you, sir. All right, bye.
Chris, I think you're not on mute.
Okay. Okay, Chris.
You're all set.
Yeah. So this slide on the left, Dave McComb had a similar slide where he's just talked about looking at his own organization, and the left-hand side represents the organization I worked for at the time, and we had tons of SaaS systems. This was just a few, and at the time I had just finished working on some systems that had to be compliant with PCI DSS, which is the security framework for very tight financial regulations. We were also looking at GDPR, which was an EU directive that was coming downstream, which was all to do with privacy, data privacy. And the diagram on the left, from a data security point of view, looked quite a nightmare. You were giving your data sovereignty and your data stewardship to what is often very small startups, many of whom didn't have any compliance to security frameworks. And this was a huge kind of risk position that many organizations find themselves in. And I felt, well, what was happening is that we were using these applications, we were bringing in these presentations of data, but we were exporting and delegating the data security and the data itself to completely different organizations. And I thought, well, actually, that's not what's important here is the data. So we should keep the data. And what's perhaps not so important and what are more ephemeral are the applications themselves. So wouldn't it be better for third parties to provide applications but not be in charge of the data, that we could somehow bring in those applications that would be stateless, and then we'd give them authorization once they're in our building to look at our apps. And wouldn't that just be a better model? Shouldn't we just invert what most institutions have today? And I think this is a lot of parallels between application-centric and data-centric. The example I gave of CSS, by the way, was really to say that this separation between applications and data is really the same as the CSS separation, in that it's the content that's important. Applications are just presentation. And in fact, they're becoming less important now, where we have AI co-workers who really don't need the flourishes and the aesthetics of a user interface and all of the the human-computer interactions, all the research that has gone into that over the years, vast amounts of investment in making computers easier to use for humans, and this is really, a lot of this can kind of be ditched today, in my view. So and this is what we see in the application-centric universe. We achieve really security by default. What we do is we have each application, like the human resources system, we just make sure the only people who can access that application are the human resources people. Or for the legal people, the only people who can access the contracts are the legal people. So we can have legal systems and HR systems. We don't have to think about security. But when we come back to bringing everything all together, suddenly we don't have that brute force advantage. We don't have that partitioning anymore. We've got to put people's salaries, medical records, health records, all in the center. And so security becomes incredibly more important. It gets surfaced. So I just give a brief kind of outline of many people, when they think of authorization, most products that can be delivered as a SaaS will allow you to define roles. So RBAC is the common NIST defined authorization regime. So RBAC stands for role-based access control, and that only gets you so far, that strategy. Eventually, you need to know something about the object that you're accessing. For example, if I wanted access to my bank account, giving me the role of someone who can access bank accounts, I shouldn't have access to Lucas's bank account just because I'm in that role. I mean, that makes no sense at all. Of course, I can only access my own bank account. And so there's something about the bank account, something about the owner of the bank account and me that has to be compared. And this is one of the bigger problems of authorization as kind of third-party services, is that in many times authorization decisions have to be a component or a function of attributes of the data that we're trying to protect. And then what do? We have to put all of the data together and load it into an authorization system. But this is the model of XACML. So this XACML is really the kind of Oasis gold standard. This is should be aware that this is how many organizations have accessed have protected their data. This was kind of I think there's got a diagram here in the XACML spec. And what happens is there's a point at which, called the PAP, where you author policies, and the policies then are accessed by a thing called a policy decision point. So at the top, the access requester, this is the web request perhaps coming in, and it talks to a policy enforcement point. That policy enforcement point is just some code, and it has to delegate that request to a context handler that will say, well, this is user allowed to access these resources. So that goes off to the policy decision point. Now, if the policy decision point needs to know anything about the data itself, who's the account owner, it then has to delegate that to a policy information point. And this thing presumably has access to all of your database resources. What I'm showing here, it's already a fairly, authorization is a fairly complex model, even done as simply as possible if you want to achieve attribute-based access control. But it does show us the way forward, and I think this is the gold standard. There is a isomorphic standard that Oasis have created, which is completely compatible with XACML, but not written in these policy languages, and not in XML. That they're in a DSL, which is much easier to read. And I'm sort of showing this to show that we kind of this is really where we want to get to long term, is to be at, because we want a policy language that is easy for policy authors to read and to write and to understand. If our policy language is in something like XML, then that's going to be difficult. So this is what we're this is, I'm sort of put this as a kind of illustrative. Let's get to this. Now, authorization is often achieved in most institutions by what you might call endpoint gating, which is really where you try to break up your website with perhaps a set of routes, and you say everything under private will go here and everything under subscriptions will go there, and you'll try and write some code, some logic that will say, well, if the person isn't logged in and the URL starts with /private, then let's not let them in. And what happens is all the authorization code is demoted to the applications itself. And so you end up continually having to roll out new versions of applications. You're putting the business logic, the application logic of authorization into the application. And this is really the kind of the state of application-centric development today, that we've optimized the ability to roll out new versions of applications very quickly. We call it continuous integration or continuous deployment or continuous delivery. And this idea has been trying to optimize the speed of delivery of applications, really to solve this problem, that every time anything changes in policy, in business logic, or in the shape of the data, then that will break the application itself, and we have to roll out the next version of application. It means our applications are incredibly brittle. They don't have to be long-lived, because they only have to live for the next 15 days or 15 hours or 15 minutes until the next version of the application is along. So this is why we've been tempted to put authorization into the application logic itself. I personally, I'm not a big fan of building thousands of applications and rolling them out every day. I think this is just completely the wrong way of doing it. What we need to do is go to declarative access control, declarative policies. And unless we provide a very good solution to this, people will just code their way out of the holes that they're in, or attempt to. Now we have kind of LLM-based development. We're just going to code much more applications, and things are just going to get worse before they get better. I wanted to compare a number of our RDF databases. So here we're kind of zooming into implementations of triple stores. I know many people on the call are kind of in the RDF space, in the semantic web. So I want to kind of touch on this. So I kind of wanted to just looked at 5 different categories of how these different RDF data stores achieve their authorization just before, and then we're going to get to a solution which, I call it a poor man's solution, that is going to be something that you can do across all of these RDF stores. And it's kind of a little cheat that I'm going to offer as a kind of, this is something that we've tried in GraphCentric. It works and it might work for you. But before we do that, we have kind of 5 categories. Named graph scoping. So something that we do in GraphCentric, but in, so we use currently Jenna Fuzeki. I should say, by the way, GraphCentric isn't an RDF database. It's a sort of layer on top of a database, in the same way Apache Web Server is a layer on top of a file system. So it's a bit of a server that's sitting and wrapping an RDF store, but it doesn't have to be. You know, you can plug in theory, when we're trying to code GraphCentric, not to use any of the extensions that these database vendors have created. So we have Fuzeki. Stardog does this, and this is Oxford Semantics database, RDFox, which is newer, uses named graph scoping. And this is where you divide the accessible named graphs. First of all, you have some mechanism of filtering which named graphs are in scope before you run your query. Then there are mechanisms which are where we do query rewriting. So we'll take the SPARQL or the SQL that's coming in, and we'll make some modifications to it to try to avoid it accessing data it's not authorized to. Virtuoso does that, and also then we come to Flurry. Flurry's got its kind of a design called flakes, but GraphDB and Allegro Graph do this, where they offer kind of per triple filtering, where they look at some aspect of the triple, maybe its type, maybe the property, and they filter on that. So there's a policy language that you write in these databases, and then there's a thing called property masking. Stardog will allow you to mark certain properties as being, they might be credit card detail as being masked in certain situations. That's not entirely sufficient, because of course, if I wanted to look at my bank balance, that's kind of different from Lucas's bank balance, and you'd want different rules to apply. And yet there are, that is useful sometimes. And then there are MarkLogic, Oracle, Neptune, which are not kind of built as triple stores, were kind of evolved into triple stores, and they have their own pre-RDF mechanisms. Okay, so I've kept you long enough. We're kind of into a little bit of home straight now, because I'm going to really talk about the way that I suppose there's a sweet spot that we use in GraphCentric, which is around named graph scoping. So I got into this because, as I mentioned before, we were doing GDPR, which was had this idea in GDPR of a data category. So rather than talking about triples, it would group things together. For example, heart rate and blood pressure. There's very little reason that a doctor would be allowed to see a patient's heart rate and not see their blood pressure and not see their temperature. So we kind of group those into a data category called vital signs. And the scheme here is really to copy the way that organizations have dealt with security and classification before. And that is that if you have a file which is top secret, you mark it as top secret, and everything in that file is considered top secret. If something's public, you'd have a public file. You have a notice board or something you publish on the web, a report, and everything in that report is considered public. So you don't have to kind of do triple level authorization on a report. You just have to publish the report, and everything, every fact in that report has, by definition, is public. So this is about trying to go back and organizing things on data classification boundaries. And what this also does is it means that if you categorize one named graph as super secret, another named graph as public, it pushes classification down into operations, because in databases like Fuzeki, named graphs, and in most RDS stores, a named graph is really a file, and it maps onto a file, and that file can be separately managed on a file system. For example, when you back up files, you might decide to back up all the secret files and encrypt them, whereas you don't need to encrypt the public files. So pushing down data classification into operations, I think, makes sense. Yes, we want to get to something much more, I suppose, refined, but I think this kind of poor man's solution, which is easy to understand and easy to implement across all the RDF stores, I think it does make sense. So what we've done in GraphCentric is that whenever we receive a request in our website, we have a single SPARQL file, which is our policy file, which allows us to query all the named graphs that are in scope for that request. You can see it here on this slide. I'll just show you this slide as a resource. This is a kind of a developer view of this web resource. It tells me which methods are available and the links that it has to other slides and so on. But one of them is here with the query scope. So we go down here, and these are all the actual graphs that are considered to be in scope for querying this data. One of them is internal decks and internal resources. And because this deck information is inside one of these resources, this internal resources, this is why this slide deck is not visible publicly today. When I publish this, if you were to go to this website yourself, you won't see this slide deck. If you log in though, and if you log in as a certain person in a certain team and you have access to internal decks, then you would see it. So it's a very coarse-grained, but very effective. Okay, we're not doing any data queries in this because it's just a static resource, but in many that we do. Okay, if we go back here to so in fact, when we do a query, the first thing that we do is figure out, it isn't a question of yes or no, it's a question of what is the filtered database that this person can see. So you might not deny a request that's looking for somebody's credit score. You might show information about their name and address, but you just might not show their credit score. But you can still show enough information, just the information that they have. And SPARQL is very, very graceful. If it can't see a particular triple because it can't see a graph, it will just strip it out of the results set. It won't abort or fail fast. And it's a really nice quality of SPARQL, which is kind of why this pattern works. Now, when you do some SPARQL, it's not, there's this feature of name graphs that you can say from named in the SPARQL query, and this gives you a for all the URIs that we return from the initial query, all the name graphs, we just inject them into here. And what that does is just reduce the size of the database that we can access. So that actually speeds up the query as well, because there are less queries for less named graphs to visit for solving the constraints that are kind of solved in the where clauses. So I am just talking about the reads here, and there are a lot of policies around who can write and who can mutate the data. In fact, I believe that reads and writes are really fundamentally different things. It's important to solve write reads in one way. The way that we solve writes is to have a sort of a pipeline of what you call them transaction functions, a pipeline of mutators that are queued up, and they each are tied to some SPARQL update. So we only update our database with SPARQL updates. Now, if you think of database stored procedures, it's very much like that. Instead of giving people access to named graphs to do whatever they like to insert and delete triples, we say the only way that you can make changes to our database is through SPARQL updates. And that means that we can control who has access to each SPARQL update. So we have one pipeline that's flowing through. It means that we can replay the writes to a database and go back in time. We can, if we choose to do so, we can say, well, what did the data set look like last year? This is a very common idea. It's called the Lambda architecture, or it's commonly known as event sourcing, where you don't make writes to tables, or you don't make any mutations. What you do is you write your mutation as a kind of function that's put into a queue. When the function arrives at the top of the queue, it then gets executed on the latest version of the database. And this avoids all sorts of things, especially it avoids the problem that you have with race conditions and transaction isolation levels, so that can allow you to get into inconsistent data sets in databases. I can talk to more on that if we have any questions. So what we have, this is just a little tour, I suppose, of the GraphCentric system. We are trying to turned the entire, we're trying to build I suppose you could call it a company operating system. We're trying to build, as Dave McComb and Semantic Arts are trying to do, trying to build all the applications that you might need to run a company, an accounting system, finance, legal, application tracking system for recruitment, sales and marketing, a sort of Salesforce, HubSpot, all of these systems all in one, because we know from working in companies that it's so important to model the relationships between things. When you have applications, you often have a lot of cracks between those applications. You have people in an HR system and people in an applicant tracking system, or you have, and data falls between the gaps. And it's what we're trying to do is go back to kind of a very principled idea, which was popularized by Tim Berners-Lee, called linked data. And it's actually the 20th anniversary since the linked data W3C note. In fact, I've got a 20 years ago. And this is really kind of a GraphCentric's manifesto. This is what we're trying to create, a linked data system for all of the applications that you might have in an organization. And these 4 principles, the first 3 we're very familiar with, this idea that we should use URIs for everything, but also the ability to talk not just to humans through application user interfaces, but talk to machines, API clients, and nowadays LLM models through providing content negotiation between different data standards, but through the same URI. And this is what I'm getting to at this slide, that this same resource can have an HTML representation, a JSON-LD representation, and a discovery of relationships to other resources. And this is the kind of the big one I think most people ignore. These are the sort of links that you have between things. If I look at the source code of this slide, for example, you can see after a bit of front matter, everything is links. And this is how we think about the web, that if we didn't have links, we wouldn't call it a web. A spider wouldn't recognize it as a web. The links are the things that really are the thing that holds it all together. And by having links, it allows application clients, but also LLMs, to very quickly discover applications and know what to do and how to. And so this is the sort of pattern that we're trying to popularize, because I think in future, more and more people's systems will have to be opened up to data clients, to LLMs. They will have to understand and discover things about systems, especially with what features, what functions are available, when to call them, what the access control is. And this is really something that has been predicted by the designers of the web through the names of these linked relations. So from these links, an LLM can tell quite a lot about what to do, how to get to the next slide. Well, it can go or go to the last slide here, or go to the next slide by clicking there. So an LLM can read the slide deck in the order that it's been designed to read. Okay, that's really the end of the talk. I'm kind of open to questions and answers, and we can have more of a discussion. These are the takeaways, that really we want to have our data policies to be part of our data in our data-centric system, that we use, that name graphs is a very, very cheap, easy way of getting quick compliance to data authorization. If you've got an authorization problem, you might be able to solve it quickly by just this trick of reducing the set of name graphs that you use in your SPARQL queries. We've seen it scale. It is kind of an easy pattern, but it does have some. The trade-off is that you do have to think about partitioning your data as a set of cabinets. Okay, that's all the content. I just wondered if there's any questions or anything that you want me to cover again, and let's sort of open it up. Oh, you're on mute, Lucas.
Thank you. Yeah, I was just saying, I saw John come off mute. I was wondering if you had something. Well, if nobody has questions right now, Malcolm, maybe there's well, here your email address is right here. Sure, this is a good way to reach out to Malcolm with more questions. And we'll also be sending out, oh, hang on one moment. Eugenio, you have a question?
Yes, actually, really nice presentation. Thank you for the tour. On the reading side, yes, it makes sense. It's clear. It's a nice way of organizing the access by this named graph. So we basically look up where the person can access, the user can access, and where not. But on the writing side, that was a bit more interesting, actually. Maybe you could elaborate a little bit on what is the proper way of controlling the updates and inserts, because
I'm very
you need
influenced.
to know which sets of triples have to go into which graph, right? So it's kind of if you have your initial model, maybe a fourth person with 3 properties go into one graph and 3 other properties go into another graph. I'm like making things up now, but you know, you need to kind of manage like what goes where somehow, and yeah, how do you do that?
Yeah, exactly, and it's a very good question. I'm just going to go to the if I go to the source code to this website, to our GraphCentric website, and then you can see it looks. This is really kind of a set of files. Now I have a directory under here called updates, and in there's all the things, all the actions that we can do. I arrived at this kind of pattern before GraphCentric. Actually, I was building a generic server called Site, but it was on a key value database rather than an RDF database. But Site had this model that every URIs were essentially the keys, and then they would map to values, and the values would be, you know, resource state. But I didn't really solve the problem of access control for reads, but I did solve the problem of access control by writes by making a rule that the only way that you could mutate the system was by running some SPARQL. So I'll show you some revoke access SPARQL here. Let's say add slide to deck. That would be something you would want to do. So we have a look at that. This is some SPARQL update, and you can still see the screen, can't you? You can still see this code, Lucas. You can.
Right. Right. Yes. I'm paying attention. Yes. Thank you.
So you can see that this adds to Slide graph resources is kind of adding to the public graph and deleting from the public graph, and some of them may be we also kind of in this writing to a graph that is created just for this transaction, so we can store things like provenance data, and then we can put in kind of where clauses and some constraints. We can also, at the beginning of this SPARQL update, we can say, well, if these conditions aren't true, then I want you to abort. We have a way of aborting where we can sort of post some advice to the transaction graph saying this is why we weren't able to run this update for you. So the constraint is mutating a data set is dangerous. You want to do it atomically. Sometimes you want to update multiple graphs at the same time, because the right way of doing that is through a transaction. And SPARQL has this wonderful sibling specification, which is not that old. It's only 10 or 12 years old, called SPARQL update. And I think this is kind of the key that unlocks the door here, because you can do all of these, you can roll all of these updates into one concept, or one thing. And then you can say, well, I'm going to lock down this particular thing. This is the action that's had, and then I give permissions on this particular update to particular people, or in the update itself, if it's an attribute based kind of, is somebody wants to debit my bank account, are they Malcolm in this case? And if they're not, or if they're not the bank manager, then we're going to reject the update. So you really, it's very different from the read side. This is really that's why they're almost jewels of each other, because if you want to partition everything by various files and folders, and then you want to say, for example, update somebody's address, and you know that it's in different places, you can do this in the 4 different graphs where the address exists atomically all at once and in a consistent manner. So this is a kind of an important pattern if you want to, and I think securing writes and securing reads are 2 fundamentally separate problems, and the problem is we tend to conflate them all in one.
Can I follow up?
Yes, please.
How do you maintain this? Do you maintain this code by the SPARQL queries by hand, or you have any like framework that keeps you that helps you to keep this kind of together? Because I could imagine that's something that you may be a fragment of a SPARQL query. If you want to change slightly the model, you might have to like project that change in multiple this kind of update queries. So how do you do that by hand, or you have something that helps you kind of see where?
Yes, it's a good question. I mean, what you're looking at here is really the code of a system. We're not an application. Everything is sitting there in the database, but we do need something which is going to enforce business logic, and that thing for us is SPARQL. So how does this get managed? Yeah, in answer to your question, used to write this SPARQL by hand, and now we use AI agents to do these updates. We have skills and rules, and as you build up a whole, your Claude MD, if you use Claude, you build up a whole load of patterns, and you say, for example, we have a rule that we always keep a catalog up to date as a sort of index to avoid ourselves doing kind of great trawls through, or for example, this pattern of using this TX graph, that idea is written into a document which the agents use. So yeah, in answer to your question, yes, it is. These are written by agents through prompts.
Thanks.
At this point.
Clear.
I should also mention that it's not obvious that when we deploy the system, we use a technique which is popularized as part of CF Engine, but it's also used in CloudFormation and Terraform and some of the DevOps tools. And it's been theorized by a professor in Oslo University called Mark Burgess. It's called promise theory. You can look up promise theory. It's kind of and the idea is that the file system is synced to the database by detecting drift. And so if I make a change to a single one of these files, it will then sync incrementally with the database. So everything in GraphCentric is stored in the database. There's nothing else. Everything is data. But how do you get it in there? Well, you can either directly mutate the database, or if you want this kind of file system idea, we're very attached to this old idea of Apache web servers and document routes. So you make a quick change with your text editor here, and then the system detects that this has changed. A bit like the old days of using FTP and FTPing a file up to a server. So that's that's also kind of a little bit of a footnote of how this works.
Cool, thanks.
Just wait and see if there's anyone else who has any questions.
Any more questions? All right. Yeah, if we don't have any more, then yeah, Malcolm, they can reach out to your email there.
Yeah, this is it's malcolm@congreve.com. The reason we don't have GraphCentric email addresses is that we decided not to have any systems that we haven't written ourselves, and we haven't yet written an email system, so we can't yet have GraphCentric email addresses. But when we do, we'll those email addresses will go into a kind of a pipeline and be part of the system. So trying to dog food everything as we go. But right now, yeah, you can reach me, and certainly I'm always going to be on that email address. Do reach out to me.
And then your newsletter, GraphCentric Weekly, that's LinkedIn, is that correct?
Yeah, it's a LinkedIn. If you just search for it on LinkedIn, it was yeah, I've sort of done that for 2 or 3 months, and trying to like I'm kind of an old. I did build an RDF system about 15 years ago, and I loved it, and then I moved away from RDF, and I've kind of come back as this kind of and really enjoying how mature all the tooling, all the ecosystem is, all of the progress that's been made in that period everything is incredibly impressive now. So it's wonderful to build applications in this technology again.
Excellent. And then is there anywhere else people can go to learn more about GraphCentric?
Yeah, there's just the GraphCentric website, which we keep up to date. So that's just graphcentric.com, and we haven't updated it for a while, but things are moving very, very quickly, and I'm sure we'll be announcing things fairly soon. But we're scaling up and taking on people and doing all that, trying to build the company and build this kind of set of apps that will make up a company operating system. Just the same as I think many other companies doing this, and I think it's really refreshing as a kind of ecosystem to get out of the kind of application-centric worldview that seems to prevail everywhere.
All right, excellent. Well, if there aren't any further questions, I just wanted to add that we have a webinar coming up on July 28th. It's by Christopher Grant, who also attended DCAF, and it's great that he showed up to hear from Malcolm again. And that is on cutting through the AI black box, an ontological framework to AI performance. And Chris goes into what is inside the AI black box, when we start making distinctions about what's going on under the hood, how does that measurably improve performance? So that was also super interesting talk. We wanted to bring Chris in here to talk about that. And I'm going to put the sign up form for that in the chat here. Just make sure that showed up. Yep. Okay. Yeah, please take a look at that. See if you're interested, sign up, spread the word. And again, feel free to reach out to Malcolm if you have more questions. All right. Thanks, everyone.
All right. Thank you.
We'll hope to see you soon.
Thanks, Lucas.
Bye.